All right, so congruent triangles. What's it mean for a triangle to be congruent? Same side lengths and angle lengths. Everything about for triangles to be the same. It's triangles with the same shape. Shape. Why is that not writing? Try again. Yeah, that's what I mean. All right, shape. There we go. And size. That means that corresponding parts, so angles and sides, are congruent. So a very important part of congruent triangles are the congruency statements. And you can really mess things up if you don't do your congruency statements correctly. Okay, so when triangles are congruent, we can write a congruency statement. So for this particular example here, we have triangle ABC is congruent to triangle DEF. It has to be in that order, or in corresponding parts order. Okay, so angle A is congruent to angle D because they have the same marking on them, right? So when their congruency statement has to be in the same order that they're congruent to one another in. Okay, so with the order of the letters matters. That's what I'm trying to tell you. You cannot change it up. Okay, it's got to be corresponding parts out of that. So valid congruency statement must match or all corresponding angles and sides, depending on what you have. If you've got angles, it's pretty easy because they're going to have the markings on them. The angles that are congruent to one another, A is congruent to D. You can tell that by the one arc mark, and then B is congruent to E by the two arc marks, and then F and C are congruent to one another. It's pretty easy then. When you start doing sides that are congruent, side AB is congruent to side DE. Again, it's with the markings there, but if you'll notice in the congruency statement, side AB, if I look at the triangle listed, AB and DE are in the same spots. And then side AC should be congruent to side DF. AC, DF. Okay, it matters where they're at in the congruency statement. That's going to be big when we go to do the proofs later on. Okay, so be careful of that. Okay. All right, Cpctc. Very difficult for me to say, but I'm going to try to use that. Cpctc means corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. So Cpctc is the abbreviation for that. So if we know two triangles are congruent, then we know that all of those pairs of angles are congruent to one another, or those corresponding parts, the angles, the sides, all of that. But it's based out of that congruency statement that's given. So let's take a little bit of practice with pulling things out of a congruency statement with no picture. Because pictures are too easy. Statements are, you got to think a little bit. All right, so let's get on the left side of that little chart, we're doing angles. On the right side, we're doing the side congruences there. So when you look at your congruency statement there, it says triangle JKL is congruent to triangle PQR. So the angles is the easy part. So angle J would be congruent to which angle? P, because it's in the same spot. Angle K would be congruent to angle Q, and angle L is congruent to angle R. Again, follow the order of the letters. J, K, L, P, Q, and R. Very easy for the angles. The sides is where we can really get mixed up sometimes, especially with no picture involved. So PQR and JKL. So I'm just going to start with the letters of JKL. JK is going to be congruent to side, or put the hat on it because it's a congruency. So it's a segment. What's the segment that it's congruent to in the other? PQ. The letters in the same spot. And then I did J and K. I'm going to do J and L. So that should be to what side? P and R. And then the last one. Write another valid congruency statement for this triangle. Means rearrange the letters in a different order, but make sure it works.
LKJ is equal to
There you go. Hard to go backwards sometimes. That would work. Several other examples of that. You could do KLJ and QRP. Just change the order, but make sure that the angles, if you use your angle relationships, make sure that they're paired up in the right spots. That's the easiest way to do that. Okay. Number 2, what are the angles? Angle W is congruent to what? Angle E, X, F, and Y sides. Y'all tell me. Okay. Next. All right, XY is congruent to FG. That works. EG. Okay. Rearrange that for another valid congruency statement. If I started with the letter X over here on the left, it could. If it goes X, Y, W, then the other one would start out with what? Okay. What if I did X, W, Y? Is that legal? Yeah, and that would be congruent to F, E, G. A lot of other correct answers to that, not just one. So to make sure that you're changing the order in the right way. All right. Number 3 there gives us triangle KPM is congruent to triangle AYC. Complete each of the following statements. So we're just filling out the congruency statements there for each corresponding part. So KM is congruent to AC. CY is congruent to PM or MP. It doesn't matter which way. We'll just do MP there. PK, YA or AY, doesn't matter which way. Angle Y, angle P, angle K, angle ACY. KMP. What's another name for angle KMP? Just still on F here. What's another name for angle KMP? angle PMK, isn't it the same thing?
Yeah.
Could I call it angle M?
No.
Why not?
That's just
I don't know.
Well, can you name an angle by one letter?
Yes.
When can you not?
This right here, this situation.
No, this situation you can. When is the situation you have to use three letters to name an angle?
A point.
When you have more than one angle coming out of a vertex. If I had another line doing that and with some other letter over here like X, then I couldn't just name this angle M. I'd have to use the three letters. That's the scenario that's going to happen when you build a more complex picture. In this situation, angle KMP, we use that way of naming because this used three letters, but it would have been just as correct if you put angle M right there. That's the same angle. Okay? And you can use just one letter because the original pictures didn't have any other angles coming out of that vertex. So the vertex in the middle, make sure of that, and then go from there. So two new congruency statements, triangle MPK. CYA, triangle CYA, and triangle YAC. Easy stuff, right? All right, this one's got some measurements in there, so we're just gonna fill it out. This is kind of like the quiz the other day. It's got some folks problems like this for some reason. All right, so they tell us that triangle STW is congruent to triangle BFN, and they give us those measurements out of that, and we want to find each missing measure. So side BN.
No,
Is that a question or an answer?
I think it's the answer.
You think it's the answer? Do y'all agree?
I agree.
Because we know that side SW and side BN are congruent to one another, so they must have the same length. That's true.
14 centimeters.
14 centimeters, because we know TW is congruent to FN, so they have to have the same length. What about BF?
17.
17 centimeters, because we know that TS and BF are congruent to one another from the congruency statement. That's what allows that to happen. Now getting the angles.
82 degrees.
82 for the top one, because W is congruent to N. And then angle B is congruent to angle S, and we know angle S is 67. We know, well, how do we get angle F, though?
Add those two together and subtract those.
Oh, we got to know something else from before. Okay, which would give us what? 31. Good job. Oh, this is nice. It's a pretty picture here. So we got triangle GHJ is congruent to triangle XYZ. Got some measurements in there and a little bit of notation there on that triangle GHJ. What does that notation tell us about that triangle? It's an isosceles because it's got two congruent sides. So side GH is 27 and side HJ is also 27. So what is GJ? 18. Yep. XY?
27.
27. ZY? 27. Let's get to those angles. Angle H? 38. Angle Z? Uh-oh.
41 and 21. Because you know that one and they have to be the same, so you can subtract 38 by 180.
And you get a lot bigger number there.
Yeah, you get a lot.
71. 71 degrees. Is that right?
I forgot to bring up the one.
That would do it. And then angle J would also be 71 degrees. Or the base angles on an isosceles are congruent to one another. So you say. Ooh, algebra, everybody's favorite. Triangle UVW is congruent to triangle TSR. Find the values of x, y, and z. All right, so what do we set 12x minus 7 equal to? Why?
Because that's the same side.
UV is congruent to TS, right? So we can set those equal to each other. Now, the reason we want to know those statements there is because when we go to do the proofs, we've got to say, oh, we know because these triangles are congruent, these sides are congruent through Cpctc, and then that allows us to set up this algebra to work that out. Okay. So x equals 5.
Yes. I was right, I know it.
I was waiting for somebody to confirm. All right, let's get y. 5y minus 33. What's it equal to? 57, because we get side RS is congruent to VW. And what's y this time? 18. Good job. And then get the z. 3z plus 14. That should be equal to 50, right? And z would be 12. Right? So good old algebra, setting them up, using our congruency statements to get there. Makes it a lot easier. Okay. So that one was dealing with the side lengths. Out of that, let's do with one that deals with angle measurements and finding x, y, and z again here. Triangle PHS is congruent to triangle CNF. Now, I'm just going to start with x. Where the j came from. 6x minus 29 equals what? 115, because angle H is congruent to angle N. So that's what allows us to set that up. And then add the 29. 144 divided by 624. That's what x is. Let's get y. 3y minus 1. What do we set that equal to? Yeah. We don't know. Okay, so we'll come back to that then. Let's go get angle, or get z. 4z minus 32 equals 36, because we know angle C is congruent to angle P. So add the 32. 68 divided by 4. 17. Good job. Z 17. All right, let's go back to that y. How can we find that out? Okay, so I can plug in my numbers. Do I really have to plug in the numbers? Because I know that angle H is congruent to angle N, so it's really 115. Doesn't matter what I plug in for x there. It should be 115 plus 36.
So minus 180.
Yeah, so that's going to be what? 29 degrees. So we're going to set that equal to 29. And then y is equal to 10. All right, so we probably could have done that with it. Okay, pretty easy stuff. Take the pictures away. Make it a little bit more difficult. When there's no pictures, it seems to be harder. But I think it's easier because the congruency statement tells you what everything goes with. So we want to find x and y for this situation with triangle DEF congruent to triangle JK. They give me that DE is equal to 18. I'm looking for something. What letter combination should I set 18 equal to?
JK.
JK. From the congruency statement, I got DE and JK coming together. So I'm going to set 3y minus 21 equals 18, because those are corresponding parts of congruent triangles. So they got to be equal to each other. Solve that. 13. Yeah. Now, got to find x. So,
When you said.
JL. DF is equal to JL.
okay, df is congruent to JL because of corresponding parts in the congruency statement. So up here, df and JL are in the same spot. So we could set these two things equal to each other. Why can I not use this 23 that EF is?
Because you don't know if they're.
What would I would have to have a statement that uses what two letters from the other triangle? If I'm using E and F, I got to have K and L. And I don't have a statement that has anything with LK or KL in it. So that's why I've got to use the DF is equal to JL. 9x minus 23 equals 7x minus 11. 2x equals 12x is 6. Is that what you said? That's right. Good job. Impressive. Good algebra. Y'all like algebra. Lying about everything else, but you like algebra. Let's do one more. QRS is congruent to MNP.
So 3y minus 21 equals 18.
3y minus 21 is equal to, where are you getting the
18 because they're corresponding.
where's the 3?
Never mind.
Yeah, I'm like, where are you getting 3y? Did I give you the wrong handout or something?
No.
All right.
Like, ain't 84, like the measurement of S plus measurement of 32 equals, plus 7y minus 4 equals 180 degrees. Because they're the same angles.
And that doesn't mean they equal 180. Angle S and angle P should be congruent to one another. Okay, adding S and R, subtracting from 180 would get you angle Q, which is congruent to M. So, all right, so measure of angle S plus measure of angle R, 84 plus 32, 180 minus 116. So that would give you the measure of angle Q. And that's 64. Is that right? 64 degrees. And then you can then set 64 degrees equal to the 17y minus 4 equals 64. Should be 4. Now, how are we going to get x? Yeah, QS is equal to MP, so we set those equal to each other, and x equals 7. Subtract 1 and divide by 2. X equals 7. Yeah, this is not hard stuff. The math part is super easy for you guys. The